Hello everyone, my name is Alexander Borovikov. I am the Customer Experience Team Lead and we are glad to welcome you today. The topic of our webinar is Introduction to the BimRv Object Model. During this webinar, we will provide the basics about the format supported by BimRv, key classes and capabilities, as well as some other points you need to pay attention to. A brief overview of our BimRv SDK. It allows to access 100% of the data that is stored in Revit files. It is absolutely independent from Autodesk Revit or any other software. So, to access Revit files data, you need just BimRv. Our SDK is implemented in cross-platform C++, thus it may be used for various operation systems. Currently, the archives are available for Windows, Linux and macOS. When talking about the file extensions that you can work with, we should name the RFA, family file, RVT, model file. Template files, RTE and RTF, are also supported, so if you need, you can read the data from these files as well. One more important point that influences the usage of BimRv SDK is the structure of the Autodesk Revit files. We can name two main terms here: storage and stream. From the structure point of view, stream is similar to file and storage is similar to folder, can contain other storages and streams. Streams contain the actual data. So now, after the initial situation is clear, let us move forward and see how we can obtain the data from the file. If you visited our previous webinars, you know that the key classes to obtain the data from the file to any ODE SDK are services and database classes. BimRv is not an exception. You need to create the services class, initialize it, and call a services class method to read the data from the file to the database. For BimRv, it is ODBM database object. Just services and database classes are not enough to work with the data. So we need to introduce two important classes, ODTF object and ODBM object. ODTF object is an interface for universal work with the classes. You can get properties in a universal manner. Dumper example illustrates it. But except property dumping, it can be hardly used for any other practical purpose. ODBM object introduces more specific options and is a base for almost everything in BimRv. Now, let us review some key classes derived from the ODBM object. ODBM element describes a basic element of the database that has an ID. The key difference between object and element is that object does not have an ID and is owned by some other element. ODBM element table. Elements are registered and stored in element tables. ODBM DB drawing. DB drawing is similar to a drawing layout. Each DB drawing keeps a set of DB view items for the drawing. It may be floor plan, cell plan, and similar. ODBM DB view. The key point about the view is that it does not own elements, does not have a list of visible elements, or something similar. It includes a set of rules and filters. Using those filters, view performs the selection of the elements that will be visualized on the view. Some more words about the element and its structure. First of all, its relation with views. Element may be selected and visualized by multiple views. At the same time, it may be so that no view selects and visualizes an element. Element itself does not have information which view is selected. As for the element structure, it consists of the following three parts. Element header, with the basic information, used for instance to select what to draw. Element, we may call it the body, main element properties, and G element. G here stands for geometry, so here we have a set of view-dependent geometries. This slide shows an RVT file being loaded. The tree control shows the structure of the ODBM database. This structure is exactly the same as the structure of the file on disk. We have a set of storages and streams with data. Now, after we know the structure and the key elements, we're able to implement visualization and export of the simplified geometry. The key idea is that we pass the database to some device and modify the draw implementation to forward the necessary geometry to the output file.
The procedure of export to PDF is illustrated in our documentation. It is quite straightforward. We need to load the PDF export model, create a PDF export instance, set the PDF export parameters, and call the export PDF method and analyze the result. Let us switch to the code and see how it is implemented. The first line, the model loading. After that, we're able to create the export. Next, we set the PDF export parameters including the source database, PDF version, and output file. After all the parameters are set, we call the export PDF method, and that's it. Now, let us take the export procedure record. We will use Autodesk BimRv for this. Load an AVT file, visualize the current selected view. Next, call the export to PDF menu item, and in the export parameters dialog, enter the path to the output PDF file. Click Export. Now let's open the output PDF and see the result. Okay, that's it.
But as you understand, such a plain data structure with just data streams is not convenient. So in BimRv, we provide several additional ways of data representation. The first one you can find in Autodesk BimRv on the Element Table tab. This representation is implemented in the same manner as Revit lookup. Elements are grouped according to type. That makes the review of the database easier. There are also two tree representations that are used to represent the data of Revit files. Those are Visualize and CDA trees. As those trees are more focused on the visualization, we should pay attention to the following. As you remember, we mentioned that an element may be selected by no views, and the views are used as the structural elements for the trees. So, if an element was not selected by any view, it will not be present in the tree.
To show the differences of the two trees, let us open the same RVP file in Autodesk Viewer and Autodesk Visualize Viewer. As you see, Autodesk Visualize Viewer shows the visualized tree. All the model elements are just a plain structure, with no connection with the original Revit elements. Properties tab also shows the parameters that are significant for the visualization. In Autodesk Viewer, we see the CDA tree. It may be more convenient from the model analysis point of view. It is easier to understand which element is represented by the tree item. The final choice of the representation is up to you and depends on your goals.
And now a couple of words about parameters and properties. Though from a user point of view they look similar, but there are significant differences which we should consider. A property is stored in the file explicitly. We can find it and its value. It becomes available right after the file is read. A parameter does not physically exist in the file. The actual value of the parameter is calculated on the fly according to some rule. This rule may be just returning some property, or returning a property of a dependent class, or calculation, for instance volume, or a combination of the variants mentioned.
To illustrate parameters, let us switch back to Autodesk BimRv and select a wall and call the parameters list. As you see in the window among the parameters, we see the volume and the area. These are calculated parameters. Let's remember the ID of the element. Now we'll switch to the tree window and let us find our element by the ID. We can scroll through the properties of the element. But anyway, we will find neither area nor volume, because those parameters do not physically exist and they are calculated on fly.
The next block is dedicated to visualization-related issues. Here we need to distinguish two terms, drawing and view. Drawing can include multiple views. The dependency between drawing and view is through viewports. Drawing has IDs of the viewports, and the viewports refer to views.
To illustrate the three representations, we will use first ODE viewer example. Here we have an RVT file being loaded, and on the left panel you can see the tree structure being created. This structure is created using the CDA approach, the Common Data Access approach, and also it uses DBView as a basic structural element. So the elements in the tree are grouped according to how they were selected by the DBViews. So you see those elements. In the right tab you can see their properties. It's also possible to obtain the native properties of the elements from the file, so to make them visible here, what point we should pay attention to. As you remember, we mentioned that views select elements according to some rules and filters, and it may happen so that an element is selected by no views. So in this case, such an element won't have its representation in this tree, and we can illustrate such an example selecting this surface. If we select this tree, we automatically switch to the corresponding item of the CDA tree in the left panel. But if we select the surface, we do not switch to any item because there is no representation of this surface in the tree. So it is visualized, but it's not represented in the tree because it was selected by no view. There is another approach of creating trees. This approach is implemented in the Open Cloud example, but it can be implemented, it may be applied for the desktop ODE viewer as well. This approach also uses CDA, the Common Data Access, but the key structural elements are not DB views, but they differ a bit. And to illustrate this difference, we can easily show you that our surface that had no representation in the tree in ODE viewer has its representation in Open Cloud viewer. This is the item. We can open its properties, at least some of them. There is some material, surface area, and etc. So both approaches, as I said, are available for you, so you can replace the existing tree in ODE viewer by the tree like used in Open Cloud. Just let us show both trees simultaneously. As you see, the number of high-level elements is larger for Open Cloud. The grouping of the elements differs as well. As you see, some elements are present here, some are not. So both approaches to form a tree and to represent the data of an RVT file in a tree structure are available for you, and the final choice depends on your goals and your intentions.
BimRv capabilities are not limited by reading data only. Some of the creation capabilities are also available. On this slide, you can see a list of entities that may be created using BimRv SDK. This list may be found in our FAQ, and more information on how to create those entities may be found in the BimRv documentation. Creation is a big and complex task, and we go on working in this area.
Now, let us have a look at the element creation. For this example, we will create a direct shape element. I have a simple application, XCreate Direct Shape, that contains an example of one direct shape element creation. This API gets a command line and parses it. We check that we received a template file, which will be used to create a new file. We check that it is an RVT or an RFA file. Next, we load the main necessary modules. After this, we read the file to a new database. When creating or editing an element, we need to create and start a new transaction. We create an empty direct shape element, add it to the base, and start filling it. We need geometry and material. For material creation, we have a separate command, and in this application, we just call it. We pass the settings for the material. When we create material count, the process is the same as for the direct shape element. We get the database to which we will add the material. We read all the settings and that we've received for the material creation. Next, to create a new element, we start a new transaction. Create the material, open it to set its parameters. Set the transparency and color. These settings are used for shaded visual style. Also, we can create operance assets and set the properties that will be used for realistic visual style. For different visual styles, colors may be different. Next, we add everything we've done to the material and close the transaction and the element. At this moment, the material is fully created in the database. Now we can use the material. We create the geometry. In the application, we have a createBox method that creates a cube. It is a boundary representation geometry. For BimRv geometry, we have BimRv builder class that allows to create BimRv in a form appropriate for the file format. We start filling in with the data, surfaces, faces, edges, and set the dependencies between faces and edges. After we are done with the BimRv geometry creation, we call the finish method. This verifies the geometry and creates the geometry in a form appropriate for the file format. Next, this geometry is added to the set of nodes and set to the element. For this example, we created only one geometry, but an element can have multiple geometries. We set the name of the element and close the transaction. At this moment, according to our settings, all the rest data of the direct shape element is bit, head, other geometry, and etc. Let us run this example application and create a file. We see the progress and the file is created and saved on disk. Now we can open, for instance, using ODE BimRv. Open the file, switch to Element Table tab, find the direct shape, we manually fill the bare direct shape with the geometry, but as you see, the G element and header were created as well. We can launch the visualization and see it. That's it. That's how we created two simple elements, material and direct shape.
And one more point that is connected with creation is the data import from Collada file. I need to pay your attention that when importing data from Collada to BimRv database, we import only geometry. That means that after import, we can see, for instance, a door, but from the model point of view, that is not a door object, but a set of geometry primitives that look like a door. Overall, the schema of Collada import looks the following. First, we read an RVT template file to ODBM database. Then we load the importer model and create the importer. We provide the properties of the importer, including the path to Collada file, and call the import method. After it, we get the modified ODBM database with the Collada geometry being imported. And now we're able to save this modified ODBM database as the output RVT file.
To illustrate the Collada import example, we will use ODE BimRv. We open an RVT file and we will visualize it. This file will be used as a template to import the Collada data. As you see, we make zoom to extents, change the visual styles, but there is actually nothing to visualize. Now, let's call the input Collada. We select the file, choose one of the settings, and import the Collada data. This may take some time. But after the input is over, we can save the newly created file to disk. Okay, now let's open the new file and let us visualize it with the same settings. As you see, we've got new data in the file imported from the Collada, but as we said, this is geometry representation only geometry. So for instance, if we open the parameter list, this window is absolutely empty.
So briefly, that is it about the BimRv object model for today. Hope you got some new and useful information. And now let us switch to the questions and answers session.
Okay. Thank you everyone for joining us today. I hope that today we managed to provide some additional and useful information. So now let us switch to the questions and answers session. So the first one was a clarification of what CDA3, what it is, as it was probably you saw that it was written that CDA stands for Common Data Access. It is an ODA approach of format-independent access to the data. We also in the answer provided the link to the corresponding documentation topic, so you can have a look if you like and review this in more details. The next question is, where is the example you showed with OpenCloud having different CDA3? I assume you can do similar CDA3 with C++ too, right? And Ivan, please, probably you can provide some additional details to what was written.
We have two examples inside BimRv project. This is CDA 3D view tree and CDA properties. Both of them contain CDA wrappers about BimRv parameters. And we created two versions CDA tree. One version is IFC style and another version is Forge style tree representation. And our visualize project and cloud projects uses these models, these examples, for showing this tree inside visualize viewer or cloud viewer. So you also can use the same examples in your application and you will get the same tree.
Okay, thank you. And let us switch to the next question. I think soon it may be provided in the examples as well. Probably in some of the next iterations, probably it's necessary to double check with the team that introduces changes to the ODE viewer, but probably there will be even an option to switch between the trees after a while, so it will be more explicit and more convenient. The next question, what about update? Can we update family parameters in RFA file? As far as I understand, this corresponds to the creation example. I think, Ivan, again, you.
Currently, we cannot yet update family parameters because this is dependent on created families and recalculation family geometry. We continue work on family import. We can import family inside model or family document, and we can collect geometry for active family now and activate symbol for active family and create instances for this. But we continue work on possibility recalculate family geometry by different parameters, because in this moment we must recalculate all forms inside by different constraints, modified basic geometry, and after modification basic geometry we must recreate family geometry by the whole building chain inside the families. And at this moment we can we already implemented possibility to create and editing all forms element, and we have Boolean operation between families. This functionality also works, but we continue working on possibility recreate sketch basing operation and recalculate full geometry. And currently this procedure not implemented fully on our site, and by this reason you cannot change parameters inside RFA files, because if you change something we must verify new data, and because if we change files the file must be correct, and if we cannot modify geometry we cannot verify new values, and in this moment it doesn't provide such possibility.
Okay, thank you. Let's move further. Is there a record of this video that one can rewatch? Sure, we will upload the record of this webinar to our YouTube channel quite shortly, so you'll be able to rewatch this webinar and the previous ones together with some educational videos and other useful materials that are provided on our YouTube channel. Any additional questions? Just as a usual adding, please feel free to address your comments, your feedback, your suggestions regarding the webinars. Probably you would like us to set up a webinar to some dedicated topic so we can analyze these possibilities. You have some time, I say we'll ask some question. Sure, we have some time, but would you like to ask it right now, or would you prefer to set up a call? Also, this possibility is also available if you wish to discuss something like face-to-face or whatever, or some topic that you consider not for a public discussion. Please let us know. Did you compare WebAssembly solution to popular game engines, Unity? It's hard to say what this comparison should look like. The thing about Unity that we can say is that it's possible to use ODE, SDKs, and Unity together. So it's possible to utilize ODE to import the geometry to Unity and visualize some, for instance, DWG model in Unity example. And we even have an example and an article about this that will shortly be published. As for the WebAssembly web solution to popular game engines, I think it's difficult to say because it's a bit different. What I mean that our cloud example was originated initially as an in-browser tool for BIM and CAD models visualization, and in game engines, as far as I know, not exact BIM or CAD models are used. So quite often some other types of the objects are used there. Speed of rendering 3D models in space. I mean, for us, mechanical drawings. Well, the general answer is that we do not have exact numbers, and we didn't perform such comparison. But it's I think a bit special question because not on all case such comparison would be correct, I would say so. If you have some dedicated questions to our cloud example, we can also set up a meeting, or you can just write an email with all the questions and all the options that you are interested in, so we can also ask our cloud team to join to this discussion or to provide the necessary information, so to provide you with the exact data on the issue. Any other issues? Any other questions? Well, then looks that's it for today. We hope no, that's good. Please the information regarding Unity integration. Could you please write me, for instance, an email, and we will send you the information that we have by now. I will provide here in the questions tab the email. Just please send me a reminder about this, and we will provide you with the existing information, because it's not like finally polished, and it's not ready just for publishing on our blog or wherever else. So, but we will be glad to share it so you can try it on your own and probably make use of it, or provide some suggestions on how to improve the current state of ODE plus Unity example. Any other questions? Well, looks that's it for today. Thank you. It was very useful. We hope we tried together. Thank you for kind words. So we tried together the key questions that appear when people start using BimRv SDK. The key probably misleading situations, just to emphasize, to pay attention to, like that restructure, which cannot be obtained, for instance, from the file. It's just a data representation built on top of the data that is stored in the file, and similar things. So then, thank you everyone for joining us, and have a nice day. Stay safe. Two small fonts when demoing code. Okay, we'll consider this. We'll consider this. Thank you very much for pointing. Okay. Then goodbye. Stay safe, and please do not hesitate to send your feedback to us. Goodbye.